Hey there, math students. Okay, first of all, this video update is not going to be 10 minutes long. I made that mistake the first time. Sorry that first one was so long. This one will be short and sweet. Okay. Oh, by the way, welcome to the second week of school. 4-day week, just like the first one. Woohoo! Okay, so for basic geometry and regular geometry and honors geometry, this week you're going to be covering segments, rays, parallel lines, and planes. The first one is the first one I mentioned is 2 days, which would be Tuesday and Wednesday this week, and then Thursday and Friday we're going to be covering measuring segments and angles, and you're going to have to get the protractor, which looks like this. It's one of those things that measures angles in degrees. Okay. Oh yeah. Also, I wanted to mention, a lot of you were asking me how to answer those questions 7, 13, and 15 on page 6 and 7 of the very first lesson. That crazy question that asked you to figure out the sequence OTTEFSSE. Okay, well, you want to know what that is? Those were the first letters of the words for the numbers 1, 2, 3, 4, 5, and so on. Number 13, the one that went like this, George John Thomas. Those were the presidents of the United States, George Washington and so forth. Number 14, Martha Abigail. Those were the first ladies, the wives of the presidents, beginning with the first one. Number 15 was a little bit more confusing. It looked like the presidents, but not quite. Well, sort of. It was the faces pictured on U.S. currency, beginning with the $1 bill. And I don't know if you know this, but there is a $2 bill, and Thomas Jefferson is on that. Okay, number 37 on page 7 of the geometry book, the one that went MVEM. You know, I taught geometry 2 years ago, and I knew it back then, and I totally forgot what this sequence was. And a shout out to Alec Enke, who helped me remember what this sequence was. This sequence was the first letter of the names of the planets in our solar system. Mercury, Venus, Earth, Mars, and then so on. Oh, and by the way, here's a quick little video of Alec Enke. I met him at the state fair a couple weeks ago. He was nice enough to drop by.
Hi, who are you?
I'm Alec Enke.
Alec Enke is one of your fellow students in geometry, so woohoo!
So yeah, Connections Academy was at the state fair this year. There's a chance we might be at the state fair next year, so if you get a chance, go to the education building. We might be there. Drop on by and say hi. Alright, so finishing up with geometry, you've got a quiz on Wednesday. It's an 11-question quiz. Numbers 5 through 11 might be a tad bit confusing, but check out 21 through 24 on page 20 of your textbook for some practice. If you can get those, then you can get the ones on the quiz for sure. Okay, moving on to those of you in Algebra 2, Basic Algebra 2. This week we're starting off with solving equations 1 in section 1-3 in your textbook. Hey, by the way, there is a technology piece on page 25, and it says optionally do numbers 1 through 3. It teaches you how to use spreadsheets. Okay, now this is one of the most underappreciated things in all of computer technology. Spreadsheets are majorly useful for lots of different things, and math, yeah, of course, but also organizing data, planning a budget, organizing whatever. So please take some time and check out number 25. That's a 2-day assignment that'll take Tuesday and Wednesday, and Thursday and Friday you will be working on solving inequalities. That is a tough one, so please be sure to come to my live lesson, which is on Wednesday at 11 a.m. I will be going over compound inequalities, which tend to give students a lot of grief. They're very difficult. So visit my live lesson on Wednesday. Oh yeah, geometry people, my live lesson is on Thursday at 11 a.m. Forgot to mention that. Okay, wrapping things up with consumer math. Department store activity, which is on Tuesday, and the grocery store assignment, which is on Wednesday and Thursday. That spans 2 days. And on Friday, you don't have anything to do. But, you know, review whatever you need to review and maybe finish up that 250 word essay from the previous week, which you might not have done. Okay, those of you in Geometry B, I want you to see a sample of some of the technology that you can use in this course too if you have the means. On page 352, number 29, there's a problem and it goes like this. Here, I'll pop it up on the screen for you. Okay, Kai used geometry software to create the figure at the right. She constructed AB and a point C not on AB. Blah, 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 blah. You can read the rest. But what we've got here is a problem where you could use some technology. And one of the things that you could get is a Ti-Nspire Calculator. The calculator has software on it that you could use, and I'm going to show it to you in just one little second. Okay, so this is what the Ti-Nspire Calculator would look like if you had it in front of you. On the left side of the screen here, we see the calculator. That's what the handheld unit looks like. And over here on the right side of the screen is a blown up view of the screen of the calculator. Now, like in the book, I've constructed some parallel lines here on the top and the bottom, and my triangle ADB. Now, right here, over to the right side, you'll see 15.86, and that is the calculated area of this triangle, given the legend here, the 1 centimeter scale. Okay, so like the book said, I can experiment around with the vertices and see what happens when I move D along the top. But first I'm going to begin with point A here. Now you'll notice that when I move it around, the area gets automatically updated, and you can see that as I get a smaller rectangle, smaller triangle, I get a smaller area, and bigger triangle, more area. Same thing if I change around vertex B. Smaller triangle, smaller area, and it recalculates it on the fly. But when I change around D, I'm moving it around, and you'll notice that the area does not change at all. And that's because the altitude is constant, and so is the base of the triangle. Okay, so you might wonder, what do I mean by the altitude? Okay, well I can add in an altitude if I hit menu, and then I go to constructions, and I add a perpendicular point here. I'm going to add in a perpendicular. Okay, so now the altitude is that line going straight up and down from vertex D to the opposite side of the triangle. And it can even go outside. So here we can really see that 1/2 base times height will be the area of any triangle.